want to show you how you can use Google Sheets to calculate the expected return and risk of a portfolio with two securities in it. So the expected return for a portfolio is just a weighted average of the expected returns of the securities in the portfolio. So here I'm going to do a two security portfolio. So it's the percentage you put in A times the expected return of A plus the weight in B times the expected return in B. And WA plus WB should add up to 100%. That is, whatever you don't put in A, you put in B. So to calculate portfolio variance, it's a little bit different. It's different because you have to account for the relationship between A and B. For example, suppose you bought 2 shares of Microsoft stock. You wouldn't expect to get any risk reduction there because if the price of Microsoft went up, then both of the shares went up in value. And if the price went down, both shares went down in value. But if you had securities that didn't move exactly together, moved in opposite directions, or at least weren't related, then you'd get some diversification benefit. If A went up and sometimes B went up, sometimes it went down, sometimes it stayed the same, some of your loss when A goes down might be offset by B just doing nothing or perhaps going up in value. And of course, if you have more securities in a portfolio, there's greater risk reduction. So how do we measure that reduction in risk? We measure it using the covariance or the correlation coefficient. So the formula for portfolio variance is the weight in A squared times the variance of A plus the weight in B squared times the variance of B plus 2 times WA times WB times the covariance between A and B. Alternatively, you can write it by substituting the the standard deviation of A times the standard deviation of B times the correlation between A and B. You can substitute because that's the same as covariance. We're going to use the second term. So covariance is a measure of the relationship between two variables. And correlation is a scaled version between -1 and +1. +1 means that you move exactly in the same direction. That is, the 2 shares of Microsoft stock. -1 means you move exactly in opposite directions. So you tell me how much A went up, I'll tell you exactly how much B went down. So insurance, homeowners insurance is, probably perfectly negatively correlated with the value of your house, right? If nothing happens to your house, the insurance company gives you nothing. If your house burns to the ground, the insurance company pays you money. So there are also securities, they don't tend to always move together. So think about, Microsoft and Ford, or Microsoft and Procter & Gamble. They're probably not going to move exactly together. You can also have securities that or assets that tend to be negatively correlated with the stock market. Gold tends to be that way. So some of you may have heard about Y2K. This is when we went from 1999 to year 2000. And there was this fear that computers in the old days only used 2 places for the year, 99. In fact, most of us usually, when we write a date, we write 23, 21, right, for the year. We don't write 2023. So there was this fear that when it went from 99 to 00, that the computers would just go haywire and that they would crash. So there were people who ran out and bought gold to protect their portfolio. So, if the computers crash and they don't recognize who I am, then all that money I have saved in the bank, nobody knows it's mine. So in this case, gold shot up in value because people bought gold. Some of them converted all their assets into gold, buried it in their backyard. If some catastrophe happened with computers, then they would be safe. So let's see if we can put these formulas into Google Sheets and then I'll show you a graph so you can get a better understanding of this relationship. So I have two securities here, A and B, and I have a standard deviation for A and a standard deviation for B, and some correlation, and I'm going to go with 0. So they're not really related. A goes up, sometimes B goes up, sometimes it stays the same, sometimes it goes down. You can see that A is safer, okay? Has lower standard deviation, but has lower expected return. So let's see what happens when we calculate the expected return for the portfolio. So let's put in the formula. The weight in A times the return of A, and I want to put a dollar sign in front of that 11, so when I copy it down, nothing happens. It doesn't move. It stays locked in cell D11. Times the weight in B plus the weight in B times the expected return of B. And again, I'm going to lock this cell. And we get 8%, right? If you don't put anything in B, you put it all in A, you get 8%. Makes sense. Let me just add a couple of decimal places here. And I'm going to copy this down. And hopefully I've done it correctly. And that looks correct, right? If you put all your money in B, you'd get a 15% expected return, right? And someplace in between there, you'll get the more B you put in, the higher your expected return. Now let's put in the portfolio standard deviation. It's going to be the square root of, and let's put these in. I'm going to separate everything with parentheses so we make sure we get this right. The weight in A squared times the variance of A, so that's the standard deviation, but we have to square it. And I got to put a dollar sign in front of that. And let me close up that parenthesis. Plus the weight in B, and again, I don't lock these cells because when I copy it down, I want these to change. And again, let me just be consistent here. So I want this to be this. And I got to square that times the standard deviation of B I'm going to lock that, and I've got to square it because I need the variance. Again, I forgot my parenthesis here. Sometimes it's good to do that so you know that everything's being done correctly. Plus 2 times WA. Whoops. Let me get back to this formula here. Plus 2 times WA times WB times the standard deviation of A. And let me see here. I'm going to have to put in that times the standard deviation of B. And again, I want to lock that cell. And then times the correlation between A and B, and I want to lock that cell. And then I want to close up the parenthesis for the square root. And hopefully I get the right answer here. And I'm going to go to percent. And let's see if I can copy this down, see if I get the right answer here. Okay, let me scroll down here. And that looks pretty good, right? 100% in A, 3% standard deviation, 100% in B, 7% standard deviation. So that looks good. So what we can do is we can see how the risk and return change if we change the correlation. Let's make this positive 1. Notice that the standard deviation just keeps going up, right? No trade-off here. Let's go to -1. You go to -1, you can actually get a portfolio that doesn't have any risk at all. And this is best seen by looking at a graph. And I've drawn the graph here. down here and I show, for example, let's go back to 0 correlation, you can see that it bends backwards. What does that mean? That means that this is A, this is only B, but by combining some risky B with your A, you actually go up, you move to the northwest. Moving north means higher expected return. Moving to the west means lower risk. You're getting higher expected return and lower risk. Okay, it's what we refer to as a free lunch. Okay, you're getting something for nothing. So the notion that you should only buy safe securities is incorrect. Adding some risky securities to a portfolio can actually reduce the amount of risk you have and increase the expected return. Now, suppose you had perfect positive correlation. Then you get this straight line here, right? That's when we did the numbers. You saw that, gee, there was no benefit from diversifying, right? No backward bend. So if you want lower risk, buy more A. You want higher return, buy more B. How about if we have -1? Here's a case where you can get 0 risk in your portfolio. And that, in the case we did here, it turns out to be 70% in A and 30% in B. So you can actually have a riskless portfolio when you have perfect negative correlation. So this is a way to do the calculations in Google Sheets, and it's a way to understand the benefits of diversification. The lower the degree of correlation, the greater the diversification benefit. So again, when you're thinking about investing, you should not have this attitude that you shouldn't buy any of a risky security. If that risky security, for example, gold, doesn't tend to move perfectly with your stock portfolio, it'll actually give you some risk reduction by adding some of it to the portfolio.